Good morning, everyone. In today's class, we'll discuss about the Unit 4. So we'll just start our today's topic with what is actually the meaning of magnetism. So we are aware of the fact that magnetism is nothing but the property of a material to get magnetized in the external magnetic field. External magnetic field, in the sense the field which is there, right, in and around a material. So that particular magnetic field is said to be an external magnetic field. So if it is getting magnetized, so such materials are known as magnetic materials. So the phenomena is known as magnetism, and the materials is known as the magnetic materials. So what is the need of studying this magnetic materials, right? To an engineering student, how it will be utilized by an engineering student, and also how in our daily life we are going to use this concept of magnetic materials, where actually we are using this magnetic materials. So first of all, we need to understand that the common use of magnetic materials. So these common use of magnetic materials, you can just see that wherever you are using a generator or cell phone, computers, right? So in particular, etc., that is completely dependent on the magnetic material. So it is one of the very important component of that particular uh, device, whatever the device we are using in our daily life. So you are aware that how usually we'll use computers, cell phones, right? And the different washing machines also. So we are using this magnetic materials there for different purposes, which is serving our household requirement, and also for engineering purpose. We, an engineering student, should have an information regarding such materials, right? The properties of such materials. So in the lower classes, you just studied about magnetic field, magnetic intensity of the magnetic field, magnetic dipole. So magnet is actually composed is a bar magnet which is having north and south pole, and we just say that is called magnetic dipole. Also, the two poles which are separated by some distance, we say that is called dipoles. If we are talking about magnet, so we'll just say magnetic dipole, and the other name is magnetic movement also. So here, these magnetic materials, depending upon the different properties, they have been classified into different what is and classifications are there. So first class magnetic material, depending upon the property, they have been classified as diamagnetic materials. So what the important properties and why these magnetic materials are said to be diamagnetic material? Because of these properties. So when we say that the diamagnetic materials, so the you don't find that right, there will be no permanent dipoles. Or just now we just had the information, right, what is actually the meaning of dipole. So here you'll not find continuous uh, what you can say, permanency will not be there in the case of diamagnetic materials. So no permanent dipoles or magnetic moments are present inside these materials. So whenever you are applying an external magnetic field, definitely there will be an induction of magnetic movement, right? Magnetic movement, or there will be the magnetic material will behave as a magnet, right? When you just external magnetic field is applied to the diamagnetic material. And how this magnetic material is since it is behaving as a magnetic material, so you are applying a magnetic field. So in which direction it will be, you are aware that you are having a particular directions in which the applied field will be there, and the magnetic materials will have a particular direction of the field. Here, for example, you are applying in a horizontally, you are applying the what you can say, and the magnetic field is applied to in a particular direction, exactly opposite, in the opposite direction, the magnetic moments are induced. So that is the reason that you can just see this the third property. We just say induced means right, it is getting right produce on that particular instant, right? So induced magnetic movement is always in the opposite direction of the applied magnetic field. So here the magnetic induction in the specimen or material, if I say specimen or a material, that is one and the same. So the magnetic induction in the given material or a specimen will definitely will be decreasing. Magnetic susceptibility, what is actually the meaning of susceptibility? A capability of the magnetic material to get magnetized. So what is that capability in this particular language of magnetism, right? So we just say that is called magnetic susceptibility. Magnetic susceptibility is nothing but the capability of the given material to get magnetized. So here the material is getting magnetized, but it is small, right? And the value, what will be the value, a particular value? Is it positive value or the negative value? So the since the magnetic susceptibility is small, therefore the value of this magnetic susceptibility is nothing but will be negative. And definitely the magnetic lines of force, magnetic lines of force ripples, right? When the case of the magnetic lines of force are rippling in the case of diamagnetic material. So diamagnetic susceptibility is independent of the temperature. Is it depending upon temperature? The what will happen if you just increase or decrease the temperature for a given magnetic material, for diamagnetic material? So it is independent. So if you increase or decrease, there will be no effect on the diamagnetic susceptibility. So and the relative permeability is less than 1. So this is a permeability is an important what you can say, a parameter which signifies the ability of the magnetic material to approach the magnetism inside the material. So that is, we just say that it's called relative permeability is less when, and that exact value is very much less than 1. So which materials will exhibit this diamagnetic material? Means what type of materials which we can see, right? So that will come under diamagnetic material. So examples are bismuth, zinc, gold, and water will also come under this category. It is known as alkali earth metals, also beryllium, magnesium, and so on. So here, this material, in the later section, you'll understand what is superconducting elements in superconducting state. So diamagnetic materials are used for producing superconductors. In the later part of our lectures, we'll just understand what is superconductors and why this superconductor come under the category of diamagnetism, right? So we'll just see that in the latest section. So this is about diamagnetic material. The next important classification that we are dealing with is paramagnetic materials, right? So what is this, how this magnetic material is different from the diamagnetic material? So they are possessing permanent dipoles when compared with the diamagnetic material. In diamagnetic material, you not find uh, permanent dipoles. Here you are possessing the permanent dipoles, and in the absence of external magnetic field, all the dipoles are randomly oriented. I will show you the diagram also what is actually dipoles look like, right? So the net magnetic moment will be 0. We just say that the magnetic moment will be 0. Now how it will be, I will show you a schematic diagram to it. So in the presence of magnetic field, the material is will get feebly magnetized, means here it will get magnetized more when compared with the diamagnetic material, slightly more when compared with the diamagnetic material here. So what it means, feebly magnetism, and also we can just say that the material which allows the magnetic lines of force. When we just compare our previous magnetic material, where you'll find that the magnetic lines of force will not be allowed, right, in the case of diamagnetic material. So now that is also an important advantage for diamagnetic material, which will be later part will discuss about superconducting. So that is a reason that we'll use diamagnetic materials for superconductors. So here, material which allows the magnetic lines of force to pass through it in the case of paramagnetic material. The orientation of magnetic dipoles, complete here, the magnetic dipoles going in a particular direction, that they actually depend upon the temperature and also the external applied field. When we compare with the diamagnetic material, the orientation of magnetic dipoles, the orientation of magnetic dipoles are independent with respect to temperature and the applied field. The susceptibility value is very small, but greater than the susceptibility of diamagnetic material. Being small also, the value of magnetic susceptibility for this magnetic material is large when compared to the diamagnetic material. So susceptibility is independent of the applied field and depends on the temperature. The susceptibility symbol, you can just see there's a susceptibility symbol is inversely proportional to 1 by T. So when I remove this proportionality, so you'll get is equal to, and this is called Curie constant. So eta susceptibility, susceptibility is denoted by this particular character, which is equal to C by T, where C is the Curie constant, and this here, this is, we just say that is called the random orientation of the dipoles, or we just say that is called magnetic movements. Clear, everybody? The magnetic is here we have the magnetic dipoles do not interact, and the materials are used in the lasers. Such paramagnetic materials are definitely used in the lasers, and also the property of the paramagnetic property of oxygen is used in your medicinal diagnosis purpose. Also, we'll use the paramagnetic property. We'll just discuss the uses of different magnetic materials, right, in the later part. So examples of the paramagnetic materials are aluminum, platinum, manganese, chromium, and etc. And alkali metals also come under the category of paramagnetic materials. Now, this is the basic difference between the diamagnetic material and the paramagnetic material. Now comes the real, what you can say, the strong magnetic material, that is called ferromagnetic material. So here they are possessing, the ferromagnetic materials are possessing net magnetic moment, and it is have a special property of spontaneous magnetization. This is completely different when we compare with the dia and paramagnetic material, right? So these ferromagnetic materials shows the magnetic property in the absence of the external. See, now we just discussed that when I say magnetism, so magnetism a material which is getting induced in the presence of external magnetic field. Here, see, after getting magnetized, if I just remove that magnetic field, their existence of the, there is an existence of the magnetic field. So the materials which are exhibiting this property is known as the ferromagnetic material, and this property of magnetization in the absence of external magnetic field, we just say that is called spontaneous magnetization. And why this spontaneous magnetization is interacting with these dipoles, and we just say that is called exchange coupling. We will just discuss the derivation of the exhibition of this exchange coupling. What is actually this exchange coupling is all about mathematically. So when placed in external magnetic field, it is gets strongly attracted, and it is strongly getting attracted in the direction of the external magnetic field. All the spins are aligned. We just say this magnetic, we just say that is called magnetic movements. These magnetic movements are, we just, you are having aware that you are having spin also. See, all these spins are aligned parallel, and they are in a particular direction. You can just see this particular schematic image where you can see that this is the special property of ferromagnetic material. So when we come towards the susceptibility, magnetic susceptibility is large when compared with the dia and para, and it is positive. The susceptibility value is given by C by T minus theta, where C is nothing but a Curie constant and T is called Curie temperature. And the temperature, if the temperature is greater than the Curie temperature, then what will happen? The material gets converted into paramagnetic material. So here, since it is dependent upon the temperature, so if the temperature is greater than the, see, this temperature is greater than the Curie temperature, so the that particular material, again the ferromagnetic material, will be converted into paramagnetic material, and they possess a property called hysteresis. This is due to which they are having a vast applications of due to this special property. We just say that is called hysteresis. So material get divided into small regions, and we say that small regions are nothing but that materials are said to be the domains, right? So we'll just discuss what is this actually domains in the very broad fashion. So examples of the ferromagnetic materials are iron, copper, nickel, and so on. So here again, depending upon this spin, as you can just see, this is the spin. So depending upon this spin, also the ferromagnetic materials again subclassified into antiferromagnetic material and ferrimagnetic material. You can just see the spin alignment is anti-parallel. The net magnetic moment here will find to be 0. Why? Because you can just see this image, right? This arrow is going upwards, that is, we'll just say a plus half, and this arrow is going downwards, and this is called the what you can say, the antiferromagnetic material. So this is about the antiferromagnetic material. So here what we have done is that we just started our today's talk with the uh, properties of different properties of the magnetic materials. And again, what we'll do is that we just start again with the properties of this uh, diamagnetic material. You can just see this again, these important properties of the magnetic materials of dia, para, and ferro. So for a minute, we'll again just go for differences between these magnetic materials, right? You can just see this the properties of diamagnetic material. You'll find that magnetic moments is, and there will be no permanent dipole, right? The external magnetic field will be produced in the induced magnetic moment. So induced magnetic moment is always in the will propagate in the opposite direction of the applied field. So the magnetic induction in the specimen decreases. The magnetic susceptibility is very small and negative, and which ripples the magnetic lines of force. Now, you can just see this is the diamagnetic susceptibility is also independent of the temperature and applied magnetic field strength. So here the relative permeability is very much less when come, and this value is less than 1. So you can just see this particular why we are going for again by this properties which you have already studied in your lower classes. Why? Because and again, if you have a good concept of this magnetic material classification, you can easily understand the later part of the topics which are there in the unit 4. Well, if you are aware of this particular facts, so definitely it will help you in understanding the character and properties and the applications of the various magnetic materials which will be used for different purposes. So right, with this, what we can say that you just I have given you the information regarding the what is actually the magnet and what is magnetism is all about. Then in the next class, we'll just see the different anti-ferro and ferri magnetic material. Again, we just will have a very quick idea about this, right? Different magnetic materials, and then we'll go to the next important uh, term of the magnetic material. Say, so here one thing that you need to remember here. So it is observed that the students uh, are strength of the students is less. So please make a note. See, whatever the doubts you are having regarding, see, if you don't understand anything, please let me know to a WhatsApp, or we'll have a doubt clarifications, right? So let us know that what is the basic problem you are facing. Then we can just sort it out by a different approach. We'll go for a different approach such that whatever the problem you are facing in understanding these topics, so that should be dealt with. So please let me know that if you are having any problem. That is the reason that since the unit 4 starting topic is there, so just take an take some time for this studying this magnetic material, the important parameters which are necessary for understanding this magnetic materials. We just see this conceptual intermediate and 10th class books such that you can understand what actually we are actually studying. Then you can easily understand the magnetic materials topic, and also how these magnetic materials are used for different application purpose, right? So now with this I'll just take a leave for today's class, and we'll just meet in the next class. Thank you, everyone. Thank you for your patience.